Alright, so today we're talking about ellipses. Ellipses are kind of a circle, but kind of not. It's when we slice through our cone at an angle, but we don't go through the base of it. Ellipses are similar to circles in the way that their equations look, but there are some key differences that you need to make sure that you understand. I took this picture right off of page 420 in your textbook. The ellipses that we're going to be dealing with this year are all centered about the origin. But the origin, or the center of the ellipse, is not the most important part. It's what's called the foci. The foci would be the two focuses, but we don't say focuses, we say foci. And then the sum of the focal radii. Those are the important pieces of information. So the distance from the center to each focus is a distance of c. One of them goes in the negative direction, one in the positive direction. The same thing if you have a vertical ellipse. One in the negative direction, one in the positive direction. To find that distance, we just use this formula. It looks like Pythagorean theorem, but it is slightly different, so please don't get them confused. Oftentimes you will be given the sum of focal radii. Whatever value it is, it's equal to 2a, and that's how you're going to find this term. Now the last thing that you need to pay attention to is the difference in the two equations. And the most important thing to think about, if you have a horizontal ellipse, that means it's along the x-axis. This value under x is going to be a larger number. If you have a vertical ellipse, that will be the y-axis, so the larger number will be under y. So that's something to pay attention to so that you can identify what kind of ellipse you're talking about. So now I'm given an equation of an ellipse. Kind of looks like the equation of a circle, but don't be fooled by this. The key thing to know, the difference between these, is that you've got these coefficients on x squared and y squared. That's how you know it's not a circle, but it's an ellipse. What you have to do is you have to get this side equal to 1. So you have to divide everything by 144. And then when you simplify, you'll end up with x squared over 16 plus y squared over 36 is equal to 1. Because the number underneath y is larger, I know that this ellipse is vertical. So I'm asked for the x-intercepts, the y-intercepts, and the foci. The x-intercepts will be the square root of that number. So my x-intercepts are going to be positive and negative 4. Right, so that's negative 4, that's positive 4. My y-intercepts will be the square root of that number. So that's positive and negative 6. Here's positive 6, there's negative 6. To find the foci, I have to use that equation, c squared is equal to a squared minus b squared. Another one of those bizarre nuances that we have to pay attention to is that a squared is always the larger number, so that's a squared. And this is b squared. So when we're looking for c squared, we take 36 minus 16 that means that c is equal to 2 root 5 positive and negative 2 root 5. So what I have to do is know that since my foci are here and here, my x-coordinates on both of them are 0. So the foci are 0, 2 root 5, and 0, negative 2 root 5. right, let's try another one. Again, I know this is an ellipse, not a circle, because there's a coefficient on one of the variables. So first thing that needs to happen, 16 needs to go to the other side. So we have x squared plus 4y squared is equal to 16. Now I need to set this equal to 1, so I divide by 16 on both sides. Let's just make that y squared instead of 1y squared. So I know that this is a horizontal ellipse because the larger value is underneath A. My x-intercepts are positive and negative 4 because I take the square root of this. My y-intercepts are positive and negative 2 because I take the square root of that. My foci, remember that's again the harder part to do. We need to find c, and we know that c squared is equal to a squared minus b squared. And again, a is always that larger value. So this becomes 2 root 3 plus or minus. So that means that the foci are, and then in this case, because it's horizontal, they're here and here, that means that my y values are 0. So it's 2 root 3, 0, and negative 2 root 3, 0. All right, so for this one, and please excuse my scribble, I clearly cut part of this problem off. We need to write the equation for the ellipse having the foci at 0, negative 3, and 0, 3, and where the sum of focal radii are 10. So again, a quick sketch, nothing major, 0, negative 3, and 0, 3. That's where my foci are. So this tells me that my ellipse is vertical. Sum of focal radii is equal to 10. So first thing we need to find is c, and c is the distance from, it's actually, you can say half the distance between these or the distance between one of them and the center. Either way, c is equal to 3. Sum of focal radii is 10, and what we have to do, that actually gives us our a value. And the formula in your textbook tells us 2 times a is the sum of focal radii. So a, in this case, is 5. That means on my major axis, my intercepts are 0, 5, and 0, negative 5. And now that I have that information, I can find the coordinates for my my x-intercepts. And for that, I will use c squared is equal to a squared minus b squared. So in this case, c squared, that's 9, is equal to 25 minus b squared. So negative 16 is equal to negative b squared divided by negative 1. 16 is b squared. Take the square root. b is plus or minus 4. So now I know the x-intercepts are 4, 0, negative 4, 0, and 4, 0. So now that I've got all this information, I've got a and b, that's really what I want. I can start to get this equation written. So I'll take x squared over something plus y squared over something, and it's equal to 1. On a vertical ellipse, my larger value has to be under y. So in this case, that is what goes under y, and it's a squared. So this is 25, and then b squared goes under the x squared. And there's the equation of our ellipse.